Now that we are comfortable with natural numbers, let us do a simple exercise. Say I have 5 chocolates with me and I give 3 of the chocolates to my friends. How many chocolates do I have left now? We can answer this simple question using natural numbers. I have 2 chocolates left with me. Now say I eat one of those chocolates in the morning. Again, how many chocolates do I have left? This question can again be answered using natural numbers. I have 1 chocolate left. Finally, after dinner I eat the remaining chocolate. How many chocolates do I finally have now? Can you use natural numbers to answer this question? All of us know the answer to this question, right? Using English, we can say that I have no chocolates left with me, or I don't have any chocolates left with me. But no or don't have any, these are not mathematical terms. How do we represent the concept of no using numbers? Let us try to answer another question. We have read that every natural number has a successor. Similar to the concept of successor, we have a concept of predecessor, which is obtained by subtracting 1 from the number. So, what is the predecessor of 14? It is 13, right? And what is the predecessor of 70? It is 69. We learnt that every natural number has a successor. This is what makes the set of natural numbers infinite. But does every natural number has a predecessor? The answer is no. And why? Well, tell me, what is the predecessor of the natural number 1? Does the natural number 1 has a predecessor, which is again a natural number? We have not read of any natural number which is smaller than 1. In fact, we said that 1 is the smallest natural number. This means that in the set of natural numbers, the number 1 does not have a predecessor. This implies that to get the predecessor of 1, we need to move beyond the concept of natural numbers. This leads us to the concept of the number 0, which in turn leads us to the concept of the set of whole numbers. So what is 0? 0 is used to denote the absence of something. Thus, the fact that I don't have any chocolates with me is represented using the number 0. If somebody asks me how many chocolates I have, I will say I have 0 chocolates. 0 is a number, though not a natural number. So what type of a number is 0? 0 is a part of a set of numbers known as whole numbers. The numbers 0, 1, 2, 3, 4, 5 and so on are called whole numbers. In other words, the natural numbers along with the number 0 form the collection of whole numbers. So the only number which is a part of the set of whole numbers but is not a part of the set of natural numbers is the number 0. 0 is what differentiates the set of whole numbers from the set of natural numbers. Just as we represented natural numbers as a set, we can also represent whole numbers as a set. The set of whole numbers is represented by the capital letter W. Thus, W is equal to 0, 1, 2, 3 and so on. We can see that all natural numbers are whole numbers, but all whole numbers are not natural numbers. 0 is a number which is a whole number, but it is not a natural number. Whole numbers are very similar to natural numbers. Let us look at 3 important properties of whole numbers. The first property is 0 is the smallest whole number. The second property is whole numbers increase in sets of 1. And the third property is just like natural numbers, there is no largest whole number. All these 3 properties are self-evident and I am sure there is no need to further explain them or to prove any of these properties. The number 0 is a unique number with many special properties. Let us look at one of the important properties of the number 0, which is division by 0. I am sure all of you know the operation of division. Let us say we divide 8 by 2. All of us know the answer to this question. 8 divided by 2 gives a quotient of 4 and a remainder of 0. But what exactly does 8 divided by 2 mean? What does division in general mean? Division of a number n by a number d means subtracting d from n repeatedly till we get either 0 or we get a number which is less than d. For example, let us divide 8 by 2. So, first let us subtract 2 from 8, which gives us 6. This is our step 1. Then we subtract 2 from 6, which gives us 4. This is our step 2. Now we do the operation of 4 minus 2, which gives us 2, step 3. And finally, we subtract 2 from 2, which gives us 0. And this is our step 4. Now we have got 0. And we got 0 in 4 steps. This means that 8 divided by 2 gives a quotient of 4 because we got 0 in 4 steps. The number of steps is equal to the quotient. So 4 is our quotient. And the number that is finally obtained, which is 0 in this case, is our remainder. So when we divide 8 by 2, we get a quotient of 4 and a remainder of 0. Let us do another example. Let us divide 11 by 3. For that, we need to subtract 3 from 11 repeatedly till either we get 0 or we get a number which is smaller than 3. So let us start. 11 minus 3 is equal to 8. This is our step 1. Now 8 minus 3 is 5. This is step 2. 5 minus 3 is 2, which is step 3. Now we have got 2, which is less than 3. Therefore, we stop our operation at this point because we cannot further subtract 3 from 2. We have arrived at our result in 3 steps. So the quotient is 3 and the final number that we have obtained is 2. So our remainder is 2. So 11 divided by 3 gives a quotient of 3 and a remainder of 2. Now, let us divide a number by 0. Let us say divide 5 by 0. In our first step, we will subtract 0 from 5. 5 minus 0 gives us 5. This is step 1. Now again we subtract 0 from 5. This is step 2. But again in step 2 we get 5. In step 3 again we subtract 0 from 5. But we have again got 5. And we can keep on doing this process for n number of times. After each step we will get 5. In fact, this process will keep repeating itself and never stop. Thus we say that 5 divided by 0 is undefined. Instead of 5 we can take any number and the result will be the same. This leads us to conclude that division of any number by 0 is undefined or is not a valid mathematical operation. Let us now learn how to represent whole numbers on the number line. We read in great detail how to represent natural numbers on the number line, and representing whole numbers on the number line is pretty similar. The only difference is that instead of starting with 1, we start with 0, since whole numbers start from 0. So we represent 0 on the number line, and then at equal distances we mark points as 1, 2, 3, 4, 5 and so on. The rightward arrow of course indicates that the set of whole numbers continue till infinity, it does not end. And now let us move on to the final topic of whole numbers, which is representing whole numbers and natural numbers in a Venn diagram. As a Venn diagram, the sets of whole numbers and natural numbers is represented as shown. As can be seen, natural numbers are a subset of whole numbers. Since the circle representing natural numbers lies completely within the circle representing whole numbers, natural numbers are a proper subset of whole numbers. In other words, every natural number is a whole number, but every whole number is not a natural number. Congratulations once again. We are now also done with the topic of whole numbers. Similar to the topic of natural numbers, in the next video, we shall learn an important limitation of whole numbers, which will again force us to expand our definition of numbers and will lead us to the concept of negative numbers, which shall enable us to introduce the concept of integers. So let us meet in the next video. Goodbye for now.